It was good. Gonna be doing some questions today. Today's just gonna be like longer because I'm gonna be reviewing all of acids and bases today. I'm just doing all the practice questions because I low key need to like lock in for acids and bases because I'm still a bit lost. Well, I mean, not like I understood it, and now it's like, yo, I low key don't know what's going on, and I have freaking the midterm on Monday, and I gotta lock in. So we're just gonna do like all of these questions right now. So it's kind of gonna be like, I don't know, like every possible kind of question right now. So we'll just see how that goes. I need to like get the questions from my computer, and then oh, today's Saturday too, right, bro? Where are these screenshots going, bro? I'm looking in a rush too, bro. I need to sleep. Most important part of studying is sleeping. Okay, calculate the pH of a 1 molar solution of dichloroacetic acid at 25 degrees Celsius. Okay, so step one, bro. Let me get my periodic table open up. Data sheet. Okay, so what is it? Dichloroacetic acid. Where's dichloroacetic acid? Okay, so this first step is find Ka. Ka is 4.5 times 10 to the 2. Okay, so what does that mean? Well, from that we could tell that this is going to be an intermediate K question. Okay, so dichloroacetic acid, what's the formula for that? So Cl2CHCOOH, solution of it, so plus H2O, liquid, becomes H3O, aqueous plus Cl2CHCOO minus aqueous, so we can make a nice table for that. So the reaction is going to be proceeding forward because there are zero products at the time. Okay, so we need to find out what X is equal to find the H3O concentration, and we know what Ka is. So we just plug this in. Products over reactants. So what is this? Intermediate case, so we'll have to actually solve for the X value. That's going to be annoying. Okay, so damn, bro, this is low-key a lot of work. Bro, what? This is like, oh my god, bro. Divided by 2. Okay, I'm not going to do this on my calculator. I have the answer key right here. So one's going to be 0.191 and negative 0.236. This is extraneous, so this is going to be the solution. So X is going to be equal to H3O. We need to find pH. So pH is negative log H3O. We should get a value of, bro, it's so dark in my room I can't even see my calculator. Negative log 0.191. Should get a value of 0.719. That's going to be pH. So there you go. pH is this. Question 1 done. Let's move on to the next. Yeah. Yo, we're cooking, bro. We're cooking. Okay, calculate the pH of 0.25 molar solution of sodium benzoate at 25 degrees. So what is sodium benzoate? Yo, and it doesn't help that my like voice is like fading away, bro. Okay, well, benzoic acid is C6H5C. So what does that mean? I believe it'll be sodium, then C6H5COO. Let me just check. Yeah. We could just scribble this out, put negative here, to form benzoic acid, which is just C6H5COOH plus H3O. Okay, so this is very similar to the previous question. What do we do now again? Okay, ice table. We need to find the Ka, but because this is the base, find the Kb value, right? Yes. Initial is 0.25 molar. Reaction is formed going forward because there's zero reactants products. Minus x 0.25 x. The nice thing about these questions is that you don't have to worry about coefficients usually. So what is the Kb value? So how do you find Kb? What is Kw? Is this on the formula sheet? Damn, it's not. Yo, I don't even, it's like 1.0 times 10 to the negative 14. 10 to the negative 14. I gotta memorize that, bro. 10 to the negative 14 divided by 0.3. Bro, I need to like turn on the light of this. 5, this is gonna be equal to 1.6 times 10 to the negative 10. Okay, so that's Kb value, so now we could just plug this in. So it's gonna be x squared over 0.25 minus x. This is a small k, so therefore 0.25 minus x equals 0.25. Wait, why am I moving into this? Three point. Oh wait, forgot to square root it seconds. So hopefully you realize that I am a bit like you're able to see like wait, how many 1 2 3 4 5 10 to the negative 6 moles. This is going to be x. this is going to be concentration of H3O. I'm trying to find pH. So again, pH equals negative log 6.3 times 10 to the negative 6. Should get a value of... Yo, doesn't mic quality sound different? I got a new pair of headphones. 5.2. Yes. Oh, no, wait. No. No. I think I set this up wrong. Yo, yeah, we would not be getting H3O. We would be getting OH. Am I dumb? That's why I was pondering, why is the charge not equal on both sides? I was like, yo, it cancels out. But nah, that's what it is. POH. So pH is going to be equal to 14 minus this. That makes way more sense. Okay, there you go. That's what I was not too sure about. 8.8? Yeah, that's right. pH is going to be 8.80. Now, because we made that assumption, let's just check that out real quick as well. Check. So what is that? 6.3 times 10 to the negative 6 divided by 0.25 times 100 equals what? Yeah, it's not. It's going to be way less than 5%. 0.003%. Less than 5%. So therefore check. So boom. That's our answer. Question 2 done. Let's move on to the next, bro. I'm actually like locked in on this, bro. I need to learn, bro. I need to learn this stuff. Otherwise, I'm gonna be like fried, bro. Like I wouldn't say like like I feel like I understand what's going on. It's just a matter of like reminding myself of what like I need to like remember. Like, you know, if I already did it and I already talked about all of these questions, I should be able to kind of. I should be able to, you know, kind of remind myself. Okay, so buffers prepared by mixing 204 mils of 0.452 HCl and 0.5 liter moles of sodium acetate. What is the pH? How do you do this? That's a good question. Yo, I look, you don't know. Okay, so HCl is a strong acid. HCl strong. Sodium acetate. What is acetate? What? Sorry, what is the pH? Strong and weak. So what does that imply then? Yo, I think I cut my eyelid. Find them. So HCl and what? What are we doing here, bro? Yo. What? What the hell? Strong acid mixed with weak acid to form a buffer solution containing the weak base and its conjugate weak acid. Find the number of moles of HCl and sodium acetate. Oh, yo, I'm so cooked, bro. Okay, so we got a strong acid plus a weak base, and then from this we'll form a conjugate acid because the strong acid is neutral plus weak base solution, right? Yo, I'm low-key confused about this. Containing the weak. Find the number of moles of HCl and sodium acetate. Yo, what? Okay, wait, let me just. Okay, so strong acid will mix with the weak base. We'll get the conjugate acid because of that weak base. Plus, we'll get the weak base in that solution, I'm assuming then. It'll contain the weak base and its conjugate weak acid. Because the HCl will completely dissociate. Okay. So then, therefore, it'll just be the conjugate acid of that base and then the weak base. So, what is the weak base again? CH3COO. Okay, because the strong acid dissociated, we'll get H3O here. Yo, this is low-key trippy. Did I do this question yet? I don't even know. So what will we get? Well, we'll get the conjugate acid then. It'll be protonated. Liquid, aqueous, ice. Okay, so now the question is, what is our initial? Oh, well, that's what we get from the. That's what we use that for. Okay, so let's find the moles. Let's do this in moles, I assume. No. Okay, CH3COO. So we got 0.5 liters multiplied by 0.4 moles per liter. Cancel. Oh my god, I have to do my post-lab report still. 0.02. Wait, what? Am I geeked? Oh yeah, what? 0.2 moles. Yo, today I was squatting and I low-key messed up my back. Okay, so now the HCl concentration will come from the HCl concentration because the HCl is completely dissociating. Okay, that low-key, well not low-key, that high-key makes sense now. Okay, let me think now. Okay, so the H3O. NH3O equals anesthetic. Is all of the what? You know, I'm low-key confused right now. Which one is the limiting reagent? H3O. Okay, so this will X just be 0.09 then? Damn, bro, I'm actually fried. What? So what will be the constant? What are we trying to find? Find the pH? Oh, we're gonna use the Hansel-Huberman freaking thing. Yo, this is low. This is high key cooked, bro. Oh my god, pH equals. Yo, the game's gone, bro. The game's gone. What are we even looking for? Okay, wait, hold on. So we're looking for this and this. Okay, so we know that x is gonna be 0.09. So this is gonna be 0.09, and then 0.2 minus 0. So this is gonna be. Which one's the base and which one's the acid? Okay, wait, this is the acid. Oh my god, bro, what the heck? What's the pKa, bro? What's the pKa? What's the pKa? Where is the formula sheet? What are we even looking at? C, acetic acid, 1.8 times 10 to the negative 5. Is that the pKa? Is that the Ka we used? Yo, what? Yes, that is. Okay, so negative log 1.76 plus log base, what's the base? 0.107 over 0.09. No, cause that's the moles. This is, oh my god, I'm getting fried. What is this, bro? Okay, so 0.09 moles divided by what's the total? Oh my god, bro. 0.704. Well, I mean, if I'm making these mistakes now, then I won't be making these mistakes in the actual exam, you know what I'm saying? So, yeah, that's the method. That's the mindset. Zero 0.153. This is equal to 4.82. There you go. That's the answer. pH. Okay, let me check with the answer key. Okay, nice. Okay, what's the next part? How many grams of KOH must be added to 0.5 liters of the buffer to change the pH by 0.15 units? Okay, so we gotta work backwards from this. Okay, so we're adding KOH. Okay, let's walk this through. I'm gonna drink some water. Okay, if we add base, therefore, the pH goes up or what? pH goes up, right? Yeah. So if you want to change by 0.15, therefore new pH is going to be equal to 4.97. Let me just make sure. 4.97. Okay, so this is the pH that we need. Now, what are we trying to find out? How much KOH must be added for the pH to change? Okay, so now if we look at this Hansel-Huberman podcast formula, 4.97 is going to be equal to negative log 0.76. Wait, why am I even writing this? Okay. What do we even do, bro? How much grams? The relevant reaction of the neutralization. Oh, okay, yo, I unlocked a core memory, bro. When we add base to buffer, react with acid. So what's the acid from this? This is CH3COOH plus what the heck? Where does the H2O? Okay, boom, 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 boom. We're cooking, bro, we're cooking. Ice. Add base to buffer, react with acid. What the heck? What the heck? What the heck? Okay, so we start with. Okay, we need to find out what. Okay, how many moles? Okay, what's the concentration of CH3COOH? 0.131. 0.131. So, in order for this to react completely, then we have to have 0.131 moles of this stuff, right? What? Oh, but we're not trying to react this fully. We're just trying to change the pH. What the heck? Oh my god. Minus X. So what is this one then? 0.153 plus X. Okay, this won't matter. I don't think so. 0.131 minus X. Oh, okay, I see. So this is the acid. This is the base. And we're going to plug this into the thing. That's what we were trying to do in the beginning. I just completely forgot about that. Oh my god, I'm so cooked, bro. Okay, so we need to solve for X. Yes, that's what we need to find out. Because then when we solve for X, that's how much. Wait, let me process this. So we're solving for X. When we find out what X is, then we find out how much OH is needed to react completely with it. So then it'll change the pH by that amount of. Okay. It makes sense. We're locked in right now. Now we're locked in. Okay, 4.97 is equal to negative log 1.76 plus log base over acid. Yo, okay, this makes sense. Negative log 1.76. You're looking almost there. 4.72. Wait, no, this is wrong. Wait, if we negative, move it to the other side as plus, right? No, not multiply. .21. Wow, it took me way too long to plug that in. So log, this is 10. What? 10? Wait, ain't that the same as log then? What am I even saying right now? So technically, we just have to put 10 to the power of. Yo, why do I low-key not know how to solve these, bro? What? 1.76 to the -5, bro. I forgot the most important thing. Oh, yo, I can't see my fucking calculator, bro. Where is this shit? Bro, I need to turn the light, but I don't want it now. Negative log 4.1.76 e -5 4.97. Yo, these negative numbers aren't like making sense anymore. What? What's going on right now? What's going on right now? What even is the equation, bro? So cooked, bro. pKa. You know what? What? Yo, I'm tweaking, bro. I'm tweaking, bro. pH is equal K, so this. Boom, boom. That makes sense. So now 4.97. Yo, why am I tweaking over math, bro? This should be the easiest part of it. Boom, boom. Why did that take me so long? Okay, so now we just gotta put 10 to the power of this, 10 to the power of that. That'll cancel out this. 1.64 equals 0.153 plus x. 0.131 minus x. Multiply that. Okay, we are not doing all that. X is equal to. Why is this glitch? X is equal to. What is it? What is it? 0.24 moles. Okay, so now what is the fucking mole? Oh, I shouldn't swear. I shouldn't be swearing, bro. X is equal to this, so C is equal to N over V. Why did I even write that? So, what do we even need? N is equal to C times V, which is equal to 0.024 moles multiplied by the volume. What is the volume? What is the volume? Why can't I think of the volume? 0.704. Or wait, what? Wait, what? Added to the 0.5 liter, okay. Moles. Now, what is the? This is KOH. What's the molar mass? What's the molar mass KOH? So 16 plus 1. Okay, I think it's about. Okay, so okay, multiplied by 56.11 grams per mole. Cancel equals 0.67 grams. Okay, that's the answer, bro. That's the answer. Okay, we'll move on to the next one. Oh my god, that was so cooked, bro. Why was I actually struggling on that so much? How many questions? 7, 8, 9, 10. 4 more questions? No. What? Yo, this is gonna take a long time. Okay, next question, bro. I guess that's what we gotta do. Okay, let's try to cook this up. Aside from okay, so the question here is, okay, what is the? I'll just write it out. Okay, I look feel like this could be cookable right now. Okay, so let's see. 500 mils solid solution consists of 0.05 moles solid NaOH, 0.13 hypochlorous acid, and HClO dissolved in water. What will happen? Okay, so what I know, NaOH will split into Na plus and then OH minus. OH minus will react with HClO. Okay, now what do I need to do? Strong, weak. So this will be a complete reaction then. So what? Let's just write out the reaction. Boom, boom. Man, this is so much work, bro. Okay, what is the concentration of each one?